Okay, so in this video we're going to determine the domain and range and how we write them according to set notation. So in this case we will say the domain of a function and range. So this is kind of just a little bit general, but we're going to talk about a polynomial. So for polynomials, and a polynomial is a type of function like quadratics. Their domain is all real numbers. So how would we write that? So in this case, we want to say there's a set. Let's put a D here for the domain. And this set is all x such that x is an element of a real number. So all these things have specific meanings. The x here, we state what variable we're going to be talking about. And then we put the parameters or the restrictions on the variable in this side of the line. And this is just x, and this is a funny looking e called epsilon, and its epsilon means it's an element, and this is a funny looking r. It's just an r with two backs, and that means real numbers. So we'll just put this here, because this is defined, and we use 3 lines to write a definition sometimes. So this means real numbers. And the other one was epsilon, and that's defined as an element. An element of something. So it's a piece of something. So now, how would we define the range? So in terms of range, that is going to be our y value or our outputs. So let's draw a little graph here. Let's say we have this, and this is our y and our x, and we're working with quadratics right now, so let's just draw a really simple one. We know that right here is our vertex, and it has the points. Let's put the vertex, just the definition. Vertex is the point P, comma, Q. But in this, I'm going to write specific numbers. So here, I'm going to say, that looks like it's about 1. And let's say right here, that's about -3. So we have the vertex is 1, -3. And the a value, it's opening upwards, so the a value is positive. So here, this is a restriction on my range. This value, the vertex, the y value of the vertex, or the q. And that just means that the function, it can't get below -3. So this line is the minimum it can go. If it opened the other way, it opened downwards, it would have a maximum value. So here, we'd write the range, and we use a set brace, and we say y such that y is an element of a real number as well, which means it can just be any number along this line, but it also has the other condition that y has to be bigger than, but it can equal -3. And that's how we'd write the set notation for the range and the domain. And that's how we're going to be writing the range and domain from now on. So that's quite important. Let's just draw another one here so we can see that what it would look like. Okay. So here is our vertex. Let's say this is 1, and that looks like it's probably about 3 as well. So now our vertex is 1, 3. We can see that the parabola doesn't go above that line, so it actually has a minimum or a maximum. So it means it must be less than. So if we were to write the range for this one, so we'll call this, that's our first one. So this is our graph 1, and then this will be our second graph. I'll put a little 2 here. So the range for the second one is going to be y such that y is an element of a real number and y has to be less than, but it can also equal 3. And if we want to discuss the domain of this, it's the same because x can be any number. As far as we keep going, but y just shoots down further and further away. And that's how we write the domain and range.